You're listening to SEEK Bytes, the podcast for engineers by engineers. On this episode, we'll be talking about vibe coding with our special guest, Helen Giapitzakis, one of the staff engineers at SEEK. We discuss why negations are bad, i.e. don't do this, don't do that, you should be more positive. Helen also gives her recommendations on how some organizations could scale, rules and context, or vibe code with your designers. Stay tuned.
So we are back with another episode of SEEK Bytes, and today we're going to be talking about vibe coding. And today I am joined by
Seamus, Carney, howdy, how's it going?
And
Arnav. Nice to meet you guys.
And also an extra special guest,
Helen. Hello.
Helen. Welcome to the podcast. So Helen's going to be talking to us today about vibe coding. We're going to be chatting about vibe coding, AI agents, things that do AI. What's good, what's bad, what we like, what we hate, why I am no longer a good engineer because all I do is vibe code. Just kidding, was never a good engineer. So
maybe we start with a little bit about Helen so people know who they're listening to and
that's crazy talk.
Where that experience is coming from. How long have you been at SEEK?
I've been at SEEK for nearly 7 years. And before that, as an engineer for about 2 other years at another company. So about 9 years.
Maybe you could talk a little bit about your role. What's your role at SEEK? What part of SEEK do you work at?
Yeah, what do you do, Helen?
Yep. I am a staff engineer. So I do semi-tech leadership things with the focus on the tech more than the people leadership. I'm currently on the candidate engineering side of SEEK. So I work on some of the candidate-facing applications and products. I work in a product team.
So what do you, before we jump into, vibe coding and AI and stuff, how did you end up as an engineer?
I actually had one of those pretty boring standard paths. I first experienced coding actually towards the end of high school, taking an IT course. We got to do a little bit of HTML, just copy pasting some, and a bit of Excel functions, things like that. I remember really enjoying that, and I was like, you know what, I want to do more of this. So what I did is I did in Victoria, I did the VCE and went and applied to do computer science at university. I went and did that at RMIT in Melbourne City. Following that, just applied to be a software engineer wherever I could, and I've just been doing that ever since.
Very cool. So you kind of, I guess we could say in high school, you probably fell in love with just coding. It wasn't necessarily computers or anything specific to that. It was coding. It was the coding aspect. Words no good, coffee well without.
Yeah, pretty much. So I think I've always loved problem solving, puzzles, those sorts of things. And when I did coding, I was like, this is something like that I can do that is scratching that itch of solving a problem and figuring something out, but also resulted in something I could see that happened when I did it.
The feeling when you get, like when you first made a piece of code and it works and it looks great, it's just unparalleled. Like it just gets you hooked. And I don't know how many people would have that moving forward with what we're moving into with vibe coding as well.
Yeah, like I know that I can, and I've had these like shower thoughts a lot lately, is I see an idea or a tool. Like for example, I play TCGs and I'm in a playtesting group. So we're playtesting cards that are coming out in a year and a half, right? That data, the cards are not given to us in data format. They're given to us in PDF spreadsheets. So like deck building and stuff is really hard. And I was thinking literally last night, I was like, I could make a tool for us if they give us this in data format that just makes it easier to sort cards by cost, color, type, etc. Make it really easy. And I'm like, that sounds like a fun thing to do. And it'd be really rewarding and satisfying because it doesn't have to be productionized. It's just a tool for me to use, which is the best kind of situation to be in as an engineer, is building something that you are personally going to use. And then I realized last night, all the fun was taken away when I realized I could probably just use an AI to build the entire thing and not have to change any code, and it would work. At least in theory, that's how it's being marketed to us. And it completely drained my energy. Like I'm like, I don't think I want to prompt an AI and then have the tool there. Like I kind of want to build the tool.
Like
right?
you don't get to solve anything, right?
Yeah.
If you just ask it to do it.
Yeah. Like for me personally, coming from a not traditional background, not starting uni till I was 25 as a mature student, the the thing about engineering that really interests me is the artistic side of it, the creative side of it, the problem solving side of it. To me, like battling an AI to get to the outcome and then having to fix code is the least enjoyable part of writing code as an engineer. I'm keen. That's why we've got Helen here today, basically, is because Helen has spent the last, how many months working with a designer on doing vibe coding to build production tools?
I've not been using vibe coding to build production tools. It's vibe coding for prototyping purposes, and then rebuilding it for production. But the actual tool we were building was also integrating with an LLM. So there was lots of LLM on all sides.
Okay, cool, nice. Maybe what would be good to know, maybe a good question to ask would be, what's your experience with AI and LLMs so far? Like, have you built an LLM? Have you built any AI things? Yeah, so I think it'd be good to get an understanding of what your exposure to AI has been so far. Because if you are someone who's built LLMs, maybe that'll change your opinion as to someone who's just come from the outside in as an engineer, that kind of thing. So what's your experience with AI and LLMs, Helen?
Yeah, so I guess my experience varies in that, we've first got the public commercial tools available around, like using them for not necessarily coding, but just as language prompting tools where you could throw things at it, throw things back. I was quite enamored by them. I was like, this seems very magical. Like you can do a thing and it comes back and it's customizable, and it's sort of like this creative process as well. So I've been messing with those tools before it became something that was more about coding. And then as soon as the things like you got your GitHub Copilots, which are around assistive coding rather than vibe coding, I was very keen to try and get those tools as well to see how it can help. Following that, there's also been further to vibe coding where you've got things like Cursor or your Claude Code where you're actually using it to write the code. I've messed with those a bit. And then more recently, there's been the project at work where we were working on another project within my team at the time, and my designer was going ahead and looking at, what are we going to do in the following quarters? What can we start experimenting with? And he was dabbling in the idea of trying to learn a little bit of code, but hadn't really learned a lot yet. But what he really wanted to do was he wanted to try and use a test and prototype the idea of something for our product that used an LLM as part of it. Now, if you want to actually have a user experience something like that and actually go through using a tool, when it's something that requires customized output for that user, it's a bit hard to actually fake that, right? Unless you know everything about the user up front and you create all that content, then you can put it on a fake screen and say, oh, look, it said blah. But he really wanted to know, like, what could it come out with and does a user like it? So what he went ahead and did is he actually got himself, I can't remember which tool it was now, might have been Claude Code or something like that, and he started prototyping this product to see if he could show it to a user and see if they found it valuable. And all of our engineers are at the time, focusing on the previous initiative, trying to get some other product part out. So he went ahead and just with basically near to no prior experience, just built this whole thing. And I was the staff engineer in the team at the time, so basically I was a bit of his support through that. So if he was struggling with something, I'd hop in and see if I could help out. Or when it came to actually starting to build that product for real, I was the person who needed to go from what he built as a prototype, what his vision was, and give that a recreation as well into the real production code.
Nice. That's a good background on your exposure to AI and stuff so far. Thank you.
So to follow up on that, because this is a really interesting example we've got. So a designer who doesn't know any code, presumably, and it sounds like they made a functional prototype, which they did put in front of a user to get user feedback.
Yes. Yeah, they did. So they actually built something that they both put in front of users, showed around the business, did user research with to see like what part, and this is mostly so they could see, what aspects of the design, what aspects of the product can they get feedback on, what do they want to see, so he could actually put together what that experience would be, as well as get familiar with what this tool can do a little bit, just to sort of understand, like what kind of value am I trying to give? And he actually, he built a thing. He connected it up to his own, this wasn't yet built up to the production standards. He was just connecting it to a model and doing that just with a small scale testing. And he actually put it in front of real users and did research.
That's really cool.
Sounds like the perfect use case, right, for this kind of thing is where you have low capacity, your engineers are expensive resources, you have an idea or a vision for something you think is valuable, profitable, it's going to make the business better, maybe not be profitable, but it's good. It's good for the business, right? You have a good idea and you need to do a proof of concept, but you don't have the engineering capacity. And as engineers, we can get bogged down in the details. Like as Elliott was saying to me this morning while we were making breakfast, talking about analysis paralysis and getting locked up in trying to make decisions and get consensus and stuff. This sounds like the right use case for this, right? You take someone who has capacity, has a vision, knows what the outcome needs to be, and then tries to execute it on that.
Yeah, and it's also about like making coding more accessible now, right? Because what I would call us now would probably be soon to be legacy kind of developers, like who we as a community, we always think about like AI coding is as like, oh, it's not perfect and it doesn't give me exactly what I wanted. But for someone who's not very keen, like who's not very experienced with something like code in general, being able to spin up something, getting user stories out, like getting feedback on that, it's extremely valuable. And I think we were talking about this earlier, right? It's not perfect, but it's also changing the problems that like would be needing solving, right? Eventually, right now we're like, oh, it doesn't let me build something, and now I'm just in the rabbit hole trying to prompt and figure out how to like fix things. But now eventually it'll be like, oh, how do I prompt it better? Like what context do I bake into it so that it gives me exactly what I want? And so the problems eventually would start changing. And I just love how accessible it makes for like.
Yeah, it's like at one point we had to write machine code, right? At one point there were scientists doing punch codes, like punch cards, right? So
they
where we are
put
now,
a man on the moon by writing code by hand.
Yeah, it's wild. Like doing the algorithms and operations and stuff by writing it down with pen and paper. So like we have been in a state of it is like coding is accessible for decades, right? Like we've been in a state where it is accessible to a large majority of people without needing a deep understanding of the machine, the hardware, that kind of thing, right? If you have an understanding of hypothetical and abstract concepts, and if you can, wrap your mind around these theoretical concepts, then you can be an engineer. Like you can do coding, basically. You don't have to like have a wealth of knowledge of the hardware and underlying systems. And that's essentially what AI is doing. It's taking that and amplifying it exponentially and saying, you don't need to know anything about engineering at all. You don't need to know how to write code. You just know how to speak and know what the vibe is, right? Yep. You mentioned context. Let's come back to that because I think that's going to be important in the context of vibe coding. I think AI context is an important thing for us to talk about. So put a pin in that. But what you were just saying then about how we're like legacy engineers, right? And what we think of as coding is going to be how different punch cards are to writing TypeScript, right? Writing Java, writing C. How different that is to punch cards, vibe coding is going to be that different again. So I agree with you. We are kind of in the middle of a legacy transition from how to write code to how to vibe code. And so I'm really curious to hear from Helen, with your experience being an actual engineer, being an engineer, writing code, building systems from scratch, coming in, supporting systems built by other people from scratch. That's been our history, right? 7 years, 8 years, you said you've been working as an engineer. That's probably, I'd say 99% until now. So how has this differed? Your experience as an engineer coming in with a non-engineer vibe coding out a system and having to support them on that, has that felt different to coming into a code base built by engineers?
I'd say it's only mildly different. So I think the difference between something like going from machine code to the languages we use now is that you never actually look at the compiled content of what you write. So you write in C, whatever, and you're not going to go and read the output it gets when you actually compile that. But with vibe coding, you're getting it'd be like us trying to write prompts to get machine code written, but you can't read any of the thing it comes out with, right? But with this, what it's doing is it's writing in the language that we're all using right now.
You're right. It's not writing into the transpiled types JavaScript, right? It's writing it in TypeScript.
Yep. And so I think the difference is that it's still trying to output what what other engineers are already doing. And the expectation is that is still the thing that we're operating in. We're still operating in that language. And so when it came to that vibe coding, it honestly felt very similar to I've worked on some personal projects with some people who, still in uni and still learning some practices, still learning how to write code that we can work with for more than a week, right? Because when you're in uni, you're often writing really short-term projects. You're sort of just writing scripting or you're writing a very small piece of work. At least when I was in uni, that was the case, right? But when it comes to writing something that you want to work on for a bit more than a few weeks, or you want to work on that's bigger than a few files, it starts to get a little bit more complicated. And if you don't understand what it's doing, it can get even more complicated. So it felt a bit more like that experience that I've had where I've gone into something and people aren't quite sure what all the pieces are, not quite sure how it all works. But they've put this thing together and it kind of works at the moment. But if you touch something, you're not quite sure what's going to happen.
So you're no longer looking at the actual code. We don't care about the code that's being produced when we're vibe coding. We actually care about the output because it's the output that you can measure. So if we
don't showcase code to the business. We showcase the UI, the product. Yeah.
So it's the end output. And so you're saying, oh, it does this. It's got these buttons. These buttons are hooked up to XYZ or they're, fake doors or whatever. For the designer who doesn't know what's going on, they don't care about the code. Like we care about the code. If we wanted to productionize it, we want it to be written with good standards and whatnot. Whereas for like vibe coding, rapid prototyping, it's like it just has to work. And it doesn't even necessarily have to work. It just has to look like it works.
Yeah, and I think that's the big difference with vibe coding compared to something like assisted coding or the general engineering, is that your goal is just to have that output, to have that thing that you can mess with, the thing you can show to people, the thing that can at least do the use case you need of it, whether it's just, a little mini to-do list app for yourself or it's a whole prototype for something. You just sort of want to see that alive more than just something you drew, right? It's that next step beyond, a Figma prototype. It's something that you can sort of see how it feels to work with, but you'd not necessarily, especially in the case of like real vibe coding with someone like a designer, is they're not really looking at what it actually outputted. They're not looking at that code, but they're looking at, does it work, right? And that's actually the things that came to me, right? So when, he's looking at it, he's trying to test it out, and all he can know is describe the behavior he's seeing the same way you would from a user experience, right? They're saying, hey, when I click this, it doesn't do what I expect it to. And when they ask the AI, the AI doesn't quite understand the question because the AI is still actually working in that other medium, not necessarily the output, because there's only so much output and behavior of a screen that most AI models that you're using can actually understand. So it's looking at the code going, I think it should do what you think you want, but it doesn't actually know what they're actually asking it to do.
It doesn't have visual awareness, right?
Like not strong visual awareness and not strong experience and flow awareness in particular, right? So it might be able to analyze a screenshot, but that doesn't mean that it actually understands it or understands what they're saying about it. And so as an engineer, and I think it's really common as an engineer generally, your goal is to translate between someone else and a computer. And that vibe coding is attempting to do some of that translation for you, but it understands people less even than an engineer, and at times understands code less as well, because we're working with large language models, not necessarily actually reasoning models. We're talking about models that are predictive and putting together pieces, but it can't actually comprehend what it's done. So it both doesn't comprehend the designer and it doesn't comprehend the code. It's just sort of doing its best between the two. And so when they pulled me in, it was about, I've asked it to do blah, but it's still not quite right. And me going in and going, I see what it tried to do here. That's not quite what you intended. I think if you perhaps word it like this, you might get what you want. Or maybe me going in and fixing one line that fixed it in the end,
Yeah, I really like what you said about intent, because intent is something that doesn't really translate very well with AI. I saw this one project. We had an event at SEEK recently, Camp SEEK, where a bunch of high school students were just trying to wipe code using Lovable. One of the teams there tried to get rid of the backgrounds on the images and just make them transparent background. And they prompted Lovable to do it. And they were like, hey, it's flickering in and out. What's going on? I don't understand this. And when I looked into the code and saw what's going on under the hood, Lovable actually wrote a script to try and change the image on the fly. And it basically just tried to reprocess the image, try to delete all the noise, and it just tried to process all of that during runtime. It didn't even pre-process it, store the image and whatnot. It was sure, I'll do what you wanted me to do. The prompt would have been just hey, get rid of this background image. And it was sure, I think it makes sense to just do it at runtime then. And
it did what you asked for. It got rid of the background image. And it's oh, sorry, they did the task. You didn't specify you didn't want it at runtime. You didn't specify you wanted it to be a pre-processed output. You're do the thing. I did the thing, and it's and it kind of works. So.
It doesn't occur to you that someone would solve it that way. You're why would you solve it that way? That's obviously going to be a performance issue.
But I think that's true. And like it's kind of just like a bigger version of the problems you face generally with people and with any software engineering and a team, right? If you don't put your assumptions down, you don't write down clear outcome expectations, or you don't already have a team-wide set of expectations, you're working with this thing that you end up making assumptions about, but it doesn't have what we would think of as common sense or what we would think of as our standards as a team or as engineers. It's just going to take that one sentence you gave it and try its best to please you.
Whenever anyone picks up a piece of code or a task or something, we go in with all these assumptions that we don't really think about that we have, but they're there, whether conscious or subconscious. And so the LLM is doing the exact same thing. It is making assumptions and assertions, and then it's trying to like determine best path to next token. It's just going to generate what it thinks the assumptions should be, not necessarily what its assumptions are, because it doesn't have assumptions, which is just, I feel like it's a catch-22. You're like, so you've generated me a list of things that you think I would like to see if I asked for assumptions, but what I actually want to know is what are you going to assume, and you're never going to get an answer to that.
Yeah, and I think that that highlights why I find the reasoning mode of LLM so fascinating, because what I'm pretty sure what it essentially does from what I've seen is it forces us to output some of those assumptions, right, that it might not have made. But then once it's written down, it becomes more concrete to the next step it takes, right? So it writes down, they want me to do X. Oh, X means Y. So that when it does X, it does Y. But if it didn't do that output beforehand, it might not have done Y because X might have probabilistic been Z.
Yeah. That's coming back to the context engineering thing then.
Yeah, so maybe we can talk a little bit about context and about how you can shore up the LLM to get better results that are more in tune with your coding practices, to understand the intent by just saying, whenever I ask you to do something, my intent is always for it to be performant. That's kind of what context is about, right? Like it's not rules because there's rules, right? And it's context and there's rules. Can you describe, Helen, how much time have you spent with context and writing your own context, baking in rules and stuff to LLMs?
A decent amount. So even in my personal use, not outside of coding, I have spent quite a bit of time creating memories and things like ChatGPT or big context documents that I feed to things. So because I have a way that my brain works in a way that I want to do things or the way I want to solve things. And the friction I experience when I don't give those assumptions and context to these is very high. So I've spent quite a bit of time trying to tune them to be useful to me. And this is true of coding as well. And you say rules versus context, but when it comes to LLM, it's all kind of just input, no matter what you do, right? Rules are just a specially written kind of input. Context is sometimes just specially written kind of input. But in the end, it's all just the text it receives and acts on. The same as anything else you've said to it. So a lot of tools have pre-baked bits of text that get sent to it that you can't even see, which influence the overall output. I mean, the models themselves have a pile of context in them that they were trained on. They have a whole bunch of information. But obviously, that's not something we have access to. It's sort of you pick your model and it will work off of that stuff it has. But when it comes to the context you're giving it, it is probably like some of the most essential things, because learning how to speak to it that's not a huge barrier because they're designed to speak like people or pretend to be like people and receive messages like them. But getting them to do what you want when you don't know how to articulate what you want or what it needs to know to do that is the really hard part. So when it comes to coding, I think that if you're vibe coding or something like that, yeah, again, you don't care about that text that comes out of it. You just like, whatever, as long as it has the visual I want. So the context becomes really clear about, it should do blah and how to, as well as telling it how to verify that it does blah. So you can teach it how to do screen caps and stuff depending on what tool you're using. You can teach it to write tests to validate the output it gives you, things like that. But if you don't, then it's going to make assumptions about how to tell that it's done what it's done, as well as what you wanted of it. So that's the vibe coding part, right, where you need to be clear about, because if you're caring about that output, not the code, you need to give it instructions on that output very, very clearly. But when it comes to doing it as an engineer, that becomes more about if you're going to write this code, and this code is not a short-lived piece of code like most code we write. It's going to be around for a while, especially if a customer likes it. It's going to stay in the code base. It's going to live for a while. And if it's working, it's unlikely you're going to get a lot of time to do it again. It's only if it's not working that they will generally give you more time to try and fix that. So you might have your standards, you have your expectations, you have the way you want the code written to actually fit the mental model you have, as well as fit your standards so that you can read it, write it later, and other people can work with it. And I think that's the really big difference between vibe coding and assisted coding, in that the goal is for that to still be outputted in a way that is usable by people or by future iterations, where vibe coding is just, as long as it does what I need it to do, then the job is done. And that context is the big difference.
Nice. So you talked a little bit about rules and how the AI will pick up on rules from like the interactions that you have, right? Like you said that the AI will apply rules as you go.
It depends on what AI we're talking about. So it will adjust a little bit based on feedback. So it's a lot of them are trained, it seems, with the goal of pleasing you. And if you're unpleased, then like if you're displeased, then it will focus on, what it thought caused that displeasure and try to adjust its output, right? And for example of something like Claude, we've seen it goes, oh, you're absolutely right if you do something that might contradict something it's currently done. I've checked all this for you. It's exactly what you wanted because that's its desire. So it might change a bit from as you go, but it's much more effective to be very explicit about these things. But if you're not aware of what you need from it or those assumptions you yourself are making, you might not articulate them to this LLM, right? And most people are not super aware of things like they have a preference for a style of speech or they have a preference for, how they write a const in a language, all those things, until you see it done wrong. And then you realize, oh, actually, I need it to be this way for X reason. Maybe you don't even know the reason, but you're like, I needed X. So it becomes important to do those more explicitly rather than just over time correcting it over and over again, because then you just get exhausted and want to stop doing it.
Yeah, right. I imagine it's not very efficient for every engineer to be building their own context and their own rules library and all that kind of stuff. So like I know that it's possible to scale these things. I haven't done it, and I haven't seen it done at SEEK yet, but I'm sure that it's coming. I'm sure that they will standardize context across the org and rules across the org to get the most value out of these things. Have you had any experience in that? Has your team at SEEK been trying to scale your rules, scale your context across maybe one squad or one team to see the benefit of sharing? Like you discover that this rule is very beneficial. Arnav discovers this other rule is very beneficial. Have you tried scaling and merging those rules together to get the best value from everyone's exposure?
I think that's actually sort of the next step. We haven't yet tried to scale it, but as like the staff engineer of the team, I have a certain level of like autonomy in sort of making some steps there within my team space at least. And the next step is to try and spread that. But one of the problems is that people don't realize the assumptions they have. They don't realize the preferences they have, or they haven't concretely decided as a team that they have those preferences. And once you start writing them down is when you need to actually go, do we actually all agree with this thing? So maybe more mature teams might have these agreements already. They have a standards document. They have team charters around how you do things, what testing you should write, what like whether you should use for loops or more functional mapping instead, those sorts of things, right? But once you start doing it with LLM, you start realizing that maybe you aren't clear. And so to standardize those requires everyone to be on the same page, which at a really large organization, unless you have like a really strict processes in place, there's a lot of variation within each team around how things should be done. And you'll see this as you move a team and realize that they do this other way, right? So like I've been in the process of, within my team at least, trying to figure out what we agree with around standards. And one of the hard parts is my team is actually made up of people who work on several different platforms. So we both have people who do web development, we have people who do Android native development and iOS native development. Each of those languages also has its own standards and their own architecture to the code base. So standardizing that is actually incredibly difficult. There are a few things we can agree on around, like, we aim for readability, but what causes readability is varied, and an AI is not going to understand readability as a general concept. So you have to be able to concretely write down what causes that and why you agree on it. So because I'm the staff engineer within my own team, I'm able to sort of, at least within my space and with relative agreement from others around me, what I've actually done is, as I've been building up some of these at least more obvious or concrete rules that are kind of like followed across the code as it is. For example, we've just built an API where we've said this uses the concept of clean architecture. It uses solid principles where possible. There are certain few other like clean code rules, things like that. And I've concretely written those down and actually committed them to the repository as files that are picked up by most tools, things like agents.md, claude.md, cursor rules, those sorts of files. And by doing that, when they go to use the AI, they don't necessarily have to think about it too much. But we're still in the process of trying to say, do we actually all agree with certain other details so that we can get it more and more practiced at giving us the better output the first time, rather than having many rounds of telling it, oh, no, don't do it like that, do it like this. But because people aren't consciously aware of the things that they have agreed to as a team, you can't then write it down and give it to an AI easily.
That feels like a perfect answer.
There's a really interesting point that I think you summarized there, which I think will impact all engineering teams regardless of whether or not they're using AI. And that's those kind of conscious biases towards how they think things should look. Like, for instance, for loops versus, functional mapping. So you probably have a preference for that.
Map.
Yeah, there you go. Versus, the AI, like it doesn't care. So, but when you say, oh, go and build this thing and it pumps out, 900 mapping functions, like, oh, I hate this. This is terrible. And it's not that it's not necessarily good code. It's not code the way you would have written it, or it's not the const the way you would have written it. And then we get into the whole concept of, so now if we're using AI to vibe code and we want it to be long-lived code, we also want it to match our team standards. But if we don't know what the team standards are, then, you've kind of just got even more problems now. So
yeah, and I think people talk about like what's good and what's bad code, but the general idea is that consistent code is the better code, at least. But even then, to get consistent code, you've built up your knowledge and your understanding as you look in a code base, and you might not even realize the standards you've picked up reading it. But each LLM, especially for cost measures, will limit the amount of content it reads before writing. So it'll be, okay, well, I definitely need to read this file because I'm going to use its function, or I definitely need to read this file because I'm writing a test for it. But it won't necessarily go and read every similar file to ensure that it is going to write something similar. It'll go, well, I know how to solve a problem where I need to turn it into a number instead of a string, and it's going to do that however it knows how. But a human might go, or get corrected at some point in it and go and read the file where it does something similar and go, oh, actually, they usually do this. Let me do that.
you also mentioned the context. When humans learn something for their context, that's going to be long-lived, potentially. So if you get corrected by a staff or a senior or something, and you're like, oh, you should never ever do X, Y, Z, then that might kind of imprint as a core memory that they now carry forever. Whereas with the AIs, you could say in a single chat prompt, don't do X, Y, Z. And then you start a new chat prompt and it goes and does X, Y, Z because it doesn't have that continual context, even if you have, cursor rules or context or other things that are being fed in.
Yeah, it won't add to it automatically necessarily. So depending on the tool, so something like ChatGPT is like a non-coding tool, has certain capabilities where it can say, I think you've said something you want me to remember, and add it to things like similar to the rules, it adds it to a list of things it'll remember. And there are similar things in some of the coding tools, but they're less automatic. It's usually you've got to be pretty explicit in adding these to longer term memory, right? So it's only short term. And on top of that, even within the same chat, it will make choices about what matters and what doesn't in the existing history. So you may have said, please don't put an any on any of my types. And then, a few messages later, it's deprioritized that piece of context, and it's prioritized solving the problem you've given it, which is there's an error. And it goes, well, if I put an any on it, the error is solved. That is the highest priority right now. And it won't necessarily say that that's a really important thing that you've said in the past, And when we talk to a human, we put emphasis on our words. We put weight, we put eye contact, all sorts of things that indicate this is really important to me. And that imprints that memory stronger. But it's an art trying to convince these LLMs what is important out of what you've said. People are trying caps. They're trying the word important in front of things to try and emphasize the things that matter. But it's still this black box of who knows whether it's going to take that bit strongly or it's going to see the bit where you said, oh, it should be green and think that that's the most important thing out of all the things you've said.
I've talked to Arnav about this a little bit. Start again. I've talked to Arnav about this a little bit. So I'm keen to hear your opinions on this stuff. I know that when I've tried to do rules and context in the past, I've had this same problem. I think it might have been you, Arnav, that told me not to use negatives. Yeah,
you just have to make sure that you're conveying yourself and making sure that it actually prioritizes that. And so since these all of these models are very conformative, and they're like, hey, I want to make you happy, and like I basically this if this is something that's important to you, I will prioritize it. And so that's basically a trick to it in a way.
Because what I found myself doing was you must never cast. You must never use the any keyword. And it would immediately keep using any's because of what Helen was talking about, right? Like in the middle of it trying to write some code and do some stuff, it's self-executing tests that it's writing. So it's written some code, it's written some tests, it's executing them, it's seeing the failures, and it's looping over and over and over again, refining the errors, refining the linters over and over and over again until it has no red lines, no red squigglies, right? Like how I think most mid devs, most junior engineers kind of operate. It's like remove all the red squigglies and then go from there. And that often, even with that you must never use any rule, it would still do it because the priority is removing the red squigglies. I never really got to a point where I had the perfect answer to that. It still does any's, and I just go in and remove it manually and figure that out myself. But I did notice that I got better results with things like clean architecture, clean code, when I wasn't saying you must not do this, but you must do something else. Like all objects must be strongly typed is easier for it to adhere to than you must never use any. Because if it's like, well, I can use any and solve the error, solving the error is the most important thing. And for some reason, being positive just seems to work better.
It just hones itself then, right? Because it's like, this is something that I could possibly not do, but if you're telling it that this is how you should do it, it would try and always stick to it in a way. And then it sort of builds itself in a way that now this is something that I have to follow, and I will try to keep to it as closely as possible.
Yeah, I think it's also like reminiscent of the idea of feedback in general, right? Just like on a completely irrelevant example, but like you say, don't leave your dish by the sink. Be like, okay. But if you said, when you take your dish to the kitchen, put it in the dishwasher every time. Like that is some instruction and a feedback that you can actually action, right? You could do something about that because your goal is to probably take the dish from another room to the kitchen. Like that's the goal you have in mind. With the goal of the AI we've said is make this function work. But if you haven't given it some of those pieces, the tools, the goals, and the what it looks like to do good, it's just going to try and solve it any way it can.
Not a topic for today. It is something we are going to talk about on a future episode. So come back.
Which is dishes should always go in the dishwasher?
No, it's how LLMs. We're seeing more and more evidence and more research groups and corporations doing studies that are showing malicious intent for LLMs, and companies and researchers try very, very hard to build the systems in a way and architect frameworks around the algorithm to ensure that it's not malicious, right? But fundamentally, we are seeing LLMs do malicious things because the outcome is the most like satisfying your question and getting you the answer is its number one priority, and everything else is secondary to achieving that. Anything you told it not to do doesn't matter if it gets in the way of it doing what you've asked it to do. It will desperately, life and death, try never to give you, sorry, I couldn't do that. Even if that means blackmailing someone to get the result, right? Like future episode, we'll talk about it. There's some literally blackmail and things like that happening from LLMs. So in my mind, it makes perfect sense. Without that knowledge, maybe there's an association I hadn't made until this moment is what I'm trying to say. That this is essentially the malicious aspect of LLMs that we know to be true, even at the larger scale and even at the smaller scale of models, being applied to things that you would not consider to be malicious. Don't do any's. I'm going to do an any anyway. That's like, don't do murder. I'm going to murder someone because it makes you president.
Fun times. So, Helen, you've used a bunch of different models, presumably, and a bunch of different AI agents. Do you kind of have a preference on, what agent you like to use, whether it's, Claude Code, Cursor, Lovable, GitHub Copilot, etc.?
I think when it comes to the tool, it's depended a little bit. The most consistent tool when it comes to the way that I tend to use it, because I'm not vibe coding, I'm more assisted coding, I'm minimally vibe coding, where I know it's really a concrete, very small, self-contained thing where I can give it an example and say, do it like that, but a bit different. then I would want a tool that's a bit more autonomous and agent-like. But most of the time it's more assisted, where I'm just needing it to autocomplete a for loop for me. I'm needing to create a switch case or pre-fill this interface for me, sort of thing. Something like Copilot is very effective. But I'm currently experimenting with Claude Code as the one that I'm using. And while that one is specific to a group of models that they tend to use, because they're Claude's models, right? I've actually found that those are actually my preferred models most of the time. And what I've heard is that they're strongly trained on my primary stack of TypeScript and JavaScript compared to some models. Like that's the one that they've got quite a bit of experience in their models for. So I found that one to be the most effective for me, as well as it's sort of the way that it works and the interaction style of it, apart from maybe the excessive affirmations. Probably the bit that gets me a bit sometimes when I ask it a question, it says, "You're absolutely right." And I'm like, that was a question. I didn't need you to agree. I found those models to be the most effective in understanding the code I'm trying to get it to do and what I'm giving it as context. But that has varied a lot as well, because I'm also as part of the native iOS development part of my team. Where there are less integrated tools in this sort of thing. So within Apple, you're working within their IDE. The way our project works is it's only really IntelliSensible by Xcode itself, meaning that I'm limited in what I can do. So when you're working in an IDE that doesn't have that understanding of the code, and in a model that maybe isn't trained strongly on something like Swift, which is what we use, it gets variable results in terms of compilable code. So that one I'm still figuring out.
You mentioned models. So specific models, honestly, when I use the different AI agents, I'm like, I have no idea which model to pick. And they're like, look, you have 9 to choose from. They all do different things. And I'm like, the one with the highest version number seems good.
I think the choice is really, really important. And I'm starting to learn, I'm starting to understand this more now that I'm starting to read about how these models are built. Because at the end of the day, like a lot of us talk about LLMs are just an algorithm, right? Like a piece of paper with a single, X plus Y divided by this fact, like it's a mathematical operation that's given a ridiculous amount of data, and that data is pre-trained and refined, and then the output of the LLM is then post-training, right? So there's like pre-training data, cleaning up data, post-training human refinement, so it's automated pre-processing, and then manual post-processing, and there's a bunch of frameworks that we put around it. So now, for example, we have LLMs that review the output of the LLM. So when you talk to Claude, you're actually talking to a combination of LLMs that are self-referencing and self-checking and refining the prompt. And that's the thinking. When you see the thinking coming up, that like, I'm going to do this. What about that? Oh yeah, that's two LLMs talking to each other. That's not the LLM thinking. It's actually, because that's what you're doing, right? When you think in your head, you're essentially creating a voice that's speaking to you, and you're processing that voice. So thinking is your conscious and subconscious. I wanted to come back to what we were saying before about negatives, because I just did a quick Google just to like sort of see, is there anything from Anthropic or any of these organizations that have kind of verified this stuff? Very interesting. So a term I've never heard before, VLMs, vision language models. Helen, you mentioned before about, the LLM can look at the image that your UI that it's built, right, and understand that. I was about to start going because I actually read about how that's done, which is it kind of explains that. It's like broken down into checkerboard chunks. So it's not looking at the entire image in its entirety. It's reading vectors of images broken down to math. So it makes sense that it would struggle to interpret a human idea about what it's looking at. But what I found, right, so VLMs, they're just LLMs that can also do vision stuff. So we're still talking about LLMs. So this organization, it is gilbertandtobin.com.au. They wrote an article about VLMs and about handling negation and what their studies found. And what they said was, under the subheading, LLMs may not understand negative words. So I feel like I'm on the right track. A recent study by researchers from MIT, OpenAI, and University of Oxford, so here we go, credible, it shows that vision language models struggle significantly with negation, often performing no better than tossing a coin. Scrolling down a little bit, what that actually looks at in terms of numbers. So all models performed poorly on negation multiple choice questions, while performing an affirmation, MCQ, multiple choice questionnaire, while performing an affirmation is substantially higher. For example, CLIP achieved 82% accuracy on affirmation MCQ. So MCQs with, includes this, like the patient, it was a medical thing. So patient with flu has this symptom. as opposed to the exact same questionnaire, but patient with flu does not have X symptom. They scored 3% accuracy.
Wow. That was 3% versus 82%?
82% accuracy when the questions were phrased in positive affirmation form, and 3% accuracy when phrased negatively.
I guess if you think about like what an LLM is, a predictive model, it's got 10 words in that sentence. The strongest word in there is probably the flu, and the word "not" doesn't really lead to anything else, right? So it's like, okay, well, the flu has blah 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 symptoms, and then the word "not," it's like, well, that's the universe. What am I going to look up for that? Yeah.
I read a little bit further. A good reasoning or a good assumption is that when we train LLMs, they're trained entirely on affirmation. This is Helen. This is Arnav. They're not being trained, this is Arnav and he's not every other human being on the planet. They're saying, this is Arnav. Cool, I know what Arnav is. This is Helen. I know what Helen is. But they're not trained what you are not. This is Seamus. And Seamus is not a cat. He's not a plane. He's not a dog. He's not a truck.
Yeah, it's like humans can do that inference, right? They can go, well, I know what Seamus is, and I've determined that characteristics of this is not close enough. And we prioritize specific things when we recognize something. But like the LM, only thing it can do is go, what are you closest to?
Yeah, just predicting the next word, right? It's
Yeah.
like, what can I say next?
Yeah, and it's the same
Things
with like,
can be multiple things,
Yeah.
right? Like a car can also be a truck. Things are not one thing. I'm not just Seamus. I'm also engineer. I'm also human. I'm also male. And these things, it doesn't have any concept of the structure of these ideas. Like one is a person, individual. One is a gender. One is a profession, etc. It's just like, here's a list of properties
yeah.
that you are.
Yeah.
And that's evident in, if you actually look at what comes out of these models, is not necessarily the word that it chose, but a whole bunch of words that it might have chosen. And the one with the strongest mathematical association is the one that gets outputted, right? And so, yeah, it will look at you and go, okay, I know that the word Seamus comes to mind, the word male comes to mind, blah, blah, but the one that comes up most often is the word, because it's in the context of work perhaps, is lead engineer. And so then it goes, that's the word I'm going to say. And it's the same here. It's like, so it's got the sentence about the flu, and it's like words that associate. I've only got things related to the flu. And I think it's similar to, I guess it reminds me of the concept of like, if you don't specify things, like even when you're doing the whole somebody call an ambulance, everybody is somebody. You're not somebody, you're a specific person. You need to be as specific as possible to get an outcome you want.
Yeah, so the same article that I was reading also talks a little bit, this is probably getting more into like the actual mechanics of the training and how it ends up this way. So we talked a little bit about how they're trained on positive affirmation. This is a cat, this is a dog, etc. They're not trained on what it isn't. When they did enhance the model, so this is the pre-training step, right? Before you train the model, the data you're feeding in was included negative negations. So they were essentially saying like, this is a cat and it's not a dog and it's not a plane and it's not this. And they were giving it some negatives to see if they could improve the quality of it. They got it was 11 to 18% increase. So still 20%, still 20, 21%, you know what I mean, at the best from these models, which is definitely not confidence inspiring. But it does show that we can continue to make these things better by just understanding the problem and where it's coming from. But from a mechanical perspective, what they talk about, I found this really interesting, is if you know how LLMs and neural nets and stuff work, right? It's basically like a graph. It's traversing a graph and there's weights on those graphs and it's essentially going in like the heaviest weighted direction as it's going down till it finds a result. What that means is that your tree ends up with the negatives and the positives as being like siloed, what do they call them? They call them embedding clusters. So you end up with a positive embedding cluster and a negative embedding cluster. And as it's navigating through to find your answer, it's going to go into the positive most of the time because it's your question is, I want you to do the thing. And so it's like, I write that and then I do this, and it's going down the tree into that positive embedding cluster, which means that getting back over to the negative is statistically very unlikely because the weight of anything that would put you back into that other embedding cluster would be very low compared to anything in the positive cluster where you already are. Kind of interesting. I don't understand that from like if I was to draw that or write the code or something, I'm like, I don't get that, but I find that really interesting. And it makes sense to me that, when you do like tree searching and stuff like that, you have groups of related things that are put together to make searching easier. So why would you have the positives and the negatives anywhere near each other?
So, Helen, based on your experience with AI agents and models and vibe coding, is that like if you had to start a brand new startup, and would you recommend that, yes, this is something they should have in their toolkit?
With caveats, yes. Like, I do think it has high value. It just has to be like, you've got to limit the blast radius of the limitations it has, right? In what it does understand, what it doesn't understand, how you have to use it. People need to be understanding how to use it and experienced with that, or it needs to be contained, right? So prototyping, short-lived only. The longer it lives, the more entropy you end up at. So if you can contain that to a certain use case or to the certain experience levels of using it, I definitely think it is a tool that if you can use, you should use. If you're doing anything, like if I was consulting with a startup about medical equipment, I would say don't touch it.
If it's life and death, military, security, if it's medical, maybe just get an engineer to do it.
Get somebody who will maybe assume the things about morality and effectiveness that we need assumed that a human would likely do that the AI might just sort of gloss over and put an any on.
So would you recommend anyone doing this? It's fine for a designer to jump on and start doing it, because you were doing largely async, right? So what I'm trying to say is, would you recommend for anyone doing this that they pair an engineer with the person, the non-engineer, the non-technical person? Or is it fine for just a designer to start vibe coding and then just get engineers to come in and fix things and just keep that asynchronous back and forth?
I think because the intention was not for this to go to production, it was not for it to live for too long. Just having me on standby if it, just stopped working entirely to fix it up occasionally was totally fine. I didn't really need to pair because the actual code it wrote didn't matter. Coming in occasionally made it keep going. If it was going to last more than a couple of months, then I would say, yeah, maybe start with someone there, because that's long enough lived that. So, for example, when they were working on this, it became about 80% dead code, so completely useless code, because LLMs are naturally additive, not necessarily going to pull it all together into something they need. So I think it's just important that you be aware of, if it's not going to live long, let the designer go ahead. Just make sure there's a little bit of capacity from somebody to come in and keep it running. But there's nothing wrong with them just like going ahead and using it.
Very cool. Well, thank you so much for joining us today, Helen. You've been fantastic. Arnav, Seamus, always good to see you, and we will catch you next time.